Hi, this is Dr. Bharadwaj. Today we are going to discuss about nature of values. So in statistics, nature of values is very important. What nature of values does is it determines what type of statistical descriptive measure has to be used or what type of statistical inferential method has to be used on a particular type of data. For example, you have data. So you need to know the nature of the data. What nature of the data? Right? So, by knowing the nature of the data and what is the relationship between different observations in the data, what you are going to decide is first one is what type of statistical descriptive measure has to be used. For example, simple one is mean. What type of mean you have to use, whether it is arithmetic mean or harmonic mean or geometric mean or weighted mean, what type of mean you have to use for this type of data when the nature is like this. Next one is same thing is also for statistical inferential method. Okay, what type of statistical inferential method you have to use for this particular type of data depends on the nature of the data. So what are these? Correlation, regression, hypothesis, all these things depends on the nature of the data. You have to understand what is the nature of the data. So for if the nature of the data is this, what type of statistical descriptive method or statistical inferential method has to be used, you have to decide. Today we will discuss in depth what are the four different types of data based on the nature, and we will see with medical examples. It is very important for you to understand this so that all the advanced concepts are very easy for you to understand. Nature of data. What is nature of data? It has an inherited mathematical relationship among the values that determine how they are combined or analyzed. So it is an inherited mathematical relationship among the data. You have 10 data points or 10 observations. How these data points are related to each other, okay, that determines how these can be analyzed and how these can be combined. Based on the nature of the data, there are four variants. One is additive data, second one is multiplicative data, third one is ratio data, fourth one is rate data. First we have to understand what type of data we have in hand, and we have to classify according to this and then apply the formulas that we are going to check in depth. First one is additive data. Additive data is simple data where values are combined by simple addition to give meaningful total. When you have set of values, when you add those values, the value which you have, the final value or added value you got will have a meaning. It is not meaningless. Okay, that type of data is additive data. Best example is, for example, consider the data of 5 patients with body temperature 97.6 degree Fahrenheit, 97.9, 98.2, 98.4, 98.6. When you add these values, the final value you get is addition of temperature of all the patients. That is valuable, and this makes sense, right? Values are absolutely fine. When you add it, they make sense. What you can say is it is the addition of body temperature of 5 patients, you can say, and it is making some sense. You can use it for further calculations. This is the first type of data, additive data. Second one is multiplicative data. When you observe different values of the data, they are related to multiplication. For example, consider the best example. We have TB, right? Tuberculosis is a disease. Tuberculosis is caused by Mycobacterium tuberculosis. It is a bacteria that causes tuberculosis. This bacteria is going to multiply every 24 hours. You have one bacteria today, it becomes 2 tomorrow, 2 becomes 4 tomorrow. In the same way, it multiplies. Take that example. You are measuring the growth rate of bacteria for 5 days. Maybe one day it is 1 million, second day it is 2 million, third day it is 4 million, fourth day 8 million, and fifth day it is 16 million. What it is doing? It is multiplying by factor of 2. 1 into 2, 2. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. It is multiplying by the factor of 2. Here you can see every 24 hours the bacteria is doubling or it is multiplying by 2. When you have this kind of data, it is known as multiplicative data. Next we go to another data, that is ratio data. Ratio data is very simple. In ratio data you have ratios, right? you can compare one value with another value. Maybe first value is twice the second value, or the second value is half the first value. You can say this way. Best example is blood glucose. You take the blood glucose levels of 5 patients. For first patient it is 100 mg per dl, for second it is 95 mg per dl, for fifth patient it is 200 mg per dl. See, you are getting the ratio here. You are comparing the ratio. What is that ratio? Number of milligrams per deciliter, right? You are getting the ratio of it, and you can see the numeric value have true zero. True zero means for a patient, when you give high insulin, the blood glucose can become zero. I have seen those cases where the patient went into coma, where the blood glucose is zero. What it means is, in ratio data, the values can have absolute zero or true zero, and when you compare, when the data values have true zero, and when you take the ratios between them, it is meaningful. For example, you can see here, for patient 1 it is 100 mg per dl, and for fifth patient it is 200 mg per dl. The blood glucose levels of fifth patient is twice that of the first patient. Here you can compare different values using ratios, and each value has a ratio. Here check mg per dl, you are calculating, uh, this is also a ratio. Okay, because of this data is considered as ratio data. Next one is rate data. Data is expressed as a ratio with time. Okay, the time component is important in rate data. For example, respiratory rate of 5 patients. The first patients have 18 per minute, second patient is 20 per minute, and again the fifth patient is 18 per minute. This is the number of beats per unit time. When there is a time component, that data is known as rate data. So based on this, first you have to decide the nature of the data, whether it is additive data or multiplicative data or ratio data or rate data. Based on that, you have to apply statistical inferential method or statistical descriptive measure. Okay, it depends on the nature of the data. Thank you.